This first section deals with variables and expressions. The introduction states that there is a concert series coming to Sioux Falls, and the price of each ticket includes the following: admittance into the concert, supper, and a night stay in the campground. A group of friends are planning on going. The cost of each ticket is $80, and they are budgeting $120 total for the price of gas and snacks for the trip. The first question says, how would you find out the cost of the trip if 3 friends decide to go? Well, there's 2 different things that we have to add up in this problem. We have the cost of tickets and gas and snacks. That's probably one of the most important things when dealing with the story problem, is to write out what it is that you need in words, and then we can go ahead and translate that into numbers. So let's go ahead and do that. I know that gas and snacks are going to cost $120 altogether, and means that I have to combine that with the cost of the tickets. Well, cost of tickets is $80 for each person, and since there's 3 friends that are going, I have to multiply that 80 times 3. In algebra, we really don't like using that multiplication sign anymore, so I'm actually going to rewrite this to say 80, and I'm going to use parentheses around the 3, because that parentheses with no operation in between the 80 and the 3 mean I'm multiplying them. And I still have to add on that 120. Well, going back to the problem, it says, how would you find out the cost of the trip? It's not asking us how much it's going to cost. So this is our answer. How would we do that? We would multiply 80 times 3, and we would add 120. Number 2 kind of follows the same concepts. Now we have 7 friends that are deciding to go, and we have to figure out how we would find out the cost. Again, we're still dealing with the cost of tickets and gas and snacks. So I still have to pay that $120 for gas and snacks no matter how many people are going. The first part is the part that's going to change, because I still have to pay $80 per ticket, but the amount of tickets changed. Now I have to multiply that by the 7 people that are going on my trip. Again, how would I find it out? That's what I would do. $80 per ticket times 7 people going plus $120 for gas and snacks. Number 3, a little bit different, because now it says what happens if we don't know how many people are going. Well, let's look it up here. We still have cost of tickets, we still have gas and snacks. No matter how many people are going, again, gas and snacks is going to cost us $120. So I know I'm going to add on that 120. No matter how many people are going, I still have $80 per ticket. The piece that I don't know is the one where I substituted in a 3 or a 7. I knew 3 people were going, so I multiplied it by 3. I knew 7 were going, so I multiplied it by 7. I don't know how many people are going, so here I kind of have a question mark. Well, in math, anytime in algebra, anytime that you have a question mark like that, we're going to put in what's called a variable. So the piece that I don't know is how many people are going. Well, we don't really like using question marks in algebra, so I'm going to represent the people going by what's called the variable p. So I'm going to get rid of that question mark, and instead I'm going to put in the variable p, which still makes me understand that I don't know how many people are going, but p sounds a little bit better than a question mark, and that's what's called a variable in math. Notice up here, that was the piece that varied. I had 3 friends going. I had 7 friends going. Now I don't know how many are going. That is the piece that's going to vary or change every time that I change my problem. I like to call this, when we set up what's called an expression, this is called an expression because we're using addition, we're using multiplication, we're using numbers as well as variables. When you set up an expression, I always like to visualize setting up what's called a function machine, because I have these 2 machines set up. This first one is prepared for you to drop in whatever number you need, and it's going to multiply that number by 80 right away. Then it's going to take whatever that answer is and add 120 to it. Okay, so algebraically, this is what it looks like. As a function machine, this is what it's going to look like a little bit later. We're setting up the machine right now. Okay, I'm going to give you just a second. Go ahead and pause the video to get out your notes and vocab for this section. The objective for this section is to write linear and algebraic expressions as part of word-to-symbol translations or to represent common settings. I did throw in algebraic there because we're not just dealing with linear expressions, and I'll explain that a little bit later. This first part deals a lot with vocab. These first two vocab we've actually already talked about, but I'm going to stop for a minute and go a little bit more in depth with them. An algebraic expression consists of sums and or products of numbers and variables. We have already set up an algebraic expression. They have some good examples, but I'm going to use these instead because we've already dealt with 80p plus 120. Notice that it consists of sums. We were adding two pieces together. We were also multiplying. 80 times p is what's called a product. In this expression, we had that variable p because we understood the amount of people going could vary. So we put in the variable p for that. Again, they give different kinds of examples down here as well. This next vocab word is called a term. A term of an expression may be a number, a variable, or a product or quotient of numbers and variables. So when we look at our expression, we actually have two terms. If we look at 80 times p, this is the product of a number and a variable. This term right here is actually called a variable term because it has a variable in it. A term can also just be a number. So if you look at 120, it's its own term as well. This is what's called a constant term. And the reason why they call it this is it's constantly going to be 120. No matter how many people are going on our trip, we're going to constantly have to add on that $120 for gas. So this algebraic expression had two terms in it. Notice that this term has two pieces, 80 and p. This term only has one. Don't confuse that with how many terms are in this expression. If you notice up here, they have 4CD divided by 3MN. That actually is one whole term. This one right here is two terms. We have 3. That addition sign breaks up the two terms. So anytime that you see an addition sign or a subtraction sign, you know that you're going to have more than one term. Multiplication and division, we can smash as many things together as possible and still have only one term. I'm not going to go over these other vocab words because these are just review, but I did put them in there in case you did need a quick review. I'm going to go ahead and move on to example 1. Again, the goal of this section is to write a word to algebra, let me go up here for a second, word to symbol translations. So here we actually have a symbol and we're going to translate this into words. They're saying write a verbal expression, which basically means write this out in words. These aren't too bad because we can just look at that, say it in our head, and write exactly what we said. So in our head, you probably said something like 3 times x to the 4th, which is exactly what we're going to write down. These type of problems actually 3 times x to the 4th. Again, these problems have more than one way you could write this. You could say the product of 3 and x to the power of 4 because we understand product means multiplication. As long as you have something in there about multiplying and that x is to the power of 4, you should be okay. Looking at B, we're going to do something like that as well. Here, notice we actually have two terms because we have that addition sign in between. That doesn't change our answer. I just wanted to bring up that vocab word. If we are adding something on there, that means that we are taking 16 more than what was in front of that. So that's how I'm going to write this one. I'm going to say 16 more than the product of 5 and z squared. Again, if you were thinking 5 times z squared plus 16, same thing. But I'm going to write it like this because we're going to see that more than quite a bit and we have to get used to it. So 16 more than the product of 5 and z squared. I'm going to go ahead and pause the video and you should do the same. Go ahead and write out the guided practice 1A and 1B. And then once you're done, play the video again and see what I have written down as the answer. Okay, remember many different ways that we can write this. 1a I decided to write as 3 less than 16 times u squared. You could have said 16 times u squared minus 3, same thing. 1b, I decided to write 1/2 of a plus the product of 6 and b divided by 7. A lot of times it's a little bit tricky for students to realize that a fraction sign actually means that you are dividing. You could say the quotient as well. So something that you might want to bring up to them. All right, looking at 2, I think my pen's going a little crazy here. Let me erase. Now we're going to do the opposite. We're going to get algebraic expressions, so we are going to get words, and we have to translate them into symbols. This table is great because it gives us many clue words that we can use to understand, are we adding, are we subtracting, multiplying, or dividing. Notice up here when I was multiplying 1/2 in a, the only word that I used for that was of. And sometimes that's the trickiest one for students to understand, that just the word of means we're multiplying. Another one that trips them up a little bit is the word quotient, understanding that that means that we are dividing. Otherwise, let's go ahead and look at these. A, again, we're writing an algebraic expression for each verbal expression. We are translating this into algebra, into letters and words, using addition, multiplication, subtraction, or division. A says a number t more than 6. There's actually 2 different ways to do this. Looking at that table, we understand more than means addition. So we are taking t and we are adding it to 6. You could also say that this is 6 more than t. 2 different ways that you can do that, because addition is what's called commutative. We can flip-flop them. It's a little bit different though for B, because it says that we have 10 less than the product of 7 and F. So anytime that you see less than, this is the trickiest one, because we actually have to write this backwards. We are taking the product of 7 and F. Product means multiplying. So we have 7 times F. Understanding in algebra, we don't like that multiplication sign anymore. So if we just squish 7 and F together, we understand we're multiplying. Less than means that we are subtracting that. So we are subtracting 10 from 7 and F. So again, stress that when you see less than, we actually have to write this backwards. This is saying that it's 10 less than the product of 7 and F. Looking at C, this says 2/3 of the volume V. Again, there's that clue word. Of means that we are actually multiplying. 2/3 we are going to write as a fraction of the volume V. Understanding that that volume word is in there, but they're just using this as a formula for some kind of geometric figure that they're using. So that's how you would write C. All right, go ahead and pause the video and try guided practice 2A and 2B, and then play when you're ready. Okay, looking at 2A, product we understand is multiplying. We also understand that we don't like to use that multiplication symbol anymore, so we're just going to squish them together. Notice how they put P first and then 6 last, but I flip-flop them. Another thing in algebra, we'd like to have numbers first and then the variable second. So 6P is the best way to write 2A. 2B, it says 1/3 of the area A. Notice that we have that of word again. So even though we're using a different word, we're still multiplying. I wrote 1/3 as a fraction of the area A, so I'm multiplying that by A. Another way that you could have actually wrote this was A over 3, which means the same thing. I would actually stick with 1/3 A, because when they're dealing with area, it's an easier way to see the relationship between them. All right, moving on to last example, dealing with real world. Again, notice how we had volume up here, area up here. These are probably the words that they're going to see when dealing with real world examples. So looking at sports marketing, it says that Mr. Martinez orders 250 keychains printed with his athletic team's logo and 500 pencils printed with their web address. We're supposed to write an algebraic expression that represents the cost of the order. Well, that's really hard to do when they don't tell us the cost of the order. So again, going back to what we did with that introduction, we didn't know how many people were going on our trip, so we gave a variable to represent that unknown quantity. So we have keychains. We know that we're buying 250 of them, but we don't know how much they cost. So I'm going to say that we're going to let keychains cost, we're going to say that that is being represented as K. The other thing that we're buying are pencils. So the pencils cost, or the cost of the pencils, we're going to represent as P. Okay, we're writing an algebraic expression that represents this. So the cost of the keychains plus the cost of the pencils. We understand that we have 250 keychains times how much each one of them costs, which we don't know. So this is where K comes into play. We have to add that to the 500 pencils that he wants to buy times how much they cost. Again, we don't know, so we're going to put a P in there. Notice how we have two different variables here. Notice another thing, that the very first thing that I did was represented what each one of those meant. I can't just put 250K plus 500P, because I'm going to have people say 250 kangaroos and 500 pandas. I'm not sure what you mean. So here's our expression that represents the cost of the total order. Their guided practice 3, I don't really like too much, because it says Katie bakes 40 pastries and makes coffee for 200 people. We're supposed to write an algebraic expression to represent this situation. Well, I'm not quite sure what this means. So what we're going to say is that she's getting paid for each pastry and for each person that comes in. So go ahead and figure out that or write an algebraic expression that represents how much she is going to make if she bakes 40 pastries and makes coffee for 200 people. And then go ahead and push play when you're ready. Okay, if we are trying to write an algebraic expression that represents how much she's getting paid for this, we would say that P equals the price of the pastry, C equals the price of coffee. So 40 times P plus 200 times C would be a good algebraic expression to represent the situation. You are now ready to start the assignment for this section.